Today our focus is on division properties of exponents, and so today we're going to be working with how do we deal with a kind of a fraction that has maybe an exponent or an exponential piece in the top and in the bottom, and what happens if the bases are alike or different, and how do we simplify that. So let's take a look at some examples. So first of all, when we are dividing and we happen to have exponents that have the same base, like in our example right here, these two bases are both a's. If we want to solve this, we're going to solve it by actually taking our letters and subtracting them. So if I do m minus n, that will give me the value that's left over. Now, we spent the last couple sections doing multiplication properties of exponents, which basically said that when we multiplied, we would add our exponents. So this is exactly the opposite, which kind of makes sense. So when we do division, we're actually going to subtract the matching exponents from, or the matching bases exponents. So in this one, 3 is my base, and I can see that these match. I'm actually going to subtract the exponents. So 7 minus 4 is going to give me 3. And 3 to the third would be 27. That would be my final answer. Now the same kind of thing is true whether it's numbers like we have here or letters that we would have here. So in this one, they both have matching bases of a, and we're going to have to subtract the exponents. So 6 minus 14 is going to be negative 8. But remember, just like the problems we did in the last couple sections, if you have a negative exponent, you can't leave it that way. So that means we're going to put it over 1. And if it's in the top and it's a negative exponent, the only way that you're going to get rid of it is to move it to the bottom. Now I still have a, except now it's a positive 8. And it's still going to be having a 1 in the top in order to keep that stuff in the bottom. So this is going to be our final answer. Now remember, a lot of the problems that we have in this section are going to have negative exponents. So we do have to remember to move them so we can deal with the problem appropriately. Okay, now the second half of this kind of section focuses on what happens when you have a fraction and it's influenced by a power on the outside. So there has to be some kind of idea of how to distribute these ends to both values. That's where our focus is going to be today. So in number 1, neither the 4 or the 5 have an exponent, so I'm going to add an exponent of 1. And I'm going to say 4 and 5 are also going to have to be my bases in the answer, at least to begin. And this 3 is going to have to be distributed to both of these exponents. So 3 times 1 is 3. 3 times 1 is 3. So if I go through and do my 4 to the third and I do my 5 to the third in my calculator, 4 to the third is going to be 64. 5 to the third is going to be 125. Now I do have to look at this fraction to see if I can reduce. If you are someone that has trouble reducing, if you think about the idea that these two numbers right here don't really have anything in common to begin with, the 2 and the 4, or the 2 and the 5, then they probably won't have anything in common here. And this one doesn't. This is going to be my final answer. Now, in number 4, the 3 and the a, neither one of them have exponents, so I'm going to add a 1 there. 3 and a are going to be my bases of my answer, and I'm going to have to distribute this negative 2 to both of these exponents. So negative 2 times 1 is negative 2. Negative 2 times 1 is negative 2. Now, really, part of our issue in this problem is that on this actual solution so far, this is a negative exponent, and so is this one. So this one really wants to go to the bottom, and this one really wants to go to the top. So on the top, I'm going to have an a squared, and on the bottom, I'm going to have my 3 squared. The only difference in this problem is this is completely fine, but I've got to multiply that 3 squared out. So 3 squared would be 3 times 3, which is 9. And this would be my final answer. Again, I have to make sure that I've dealt with any negative exponents if they exist. And I also have to make sure that I multiply any numbers out like this, that 3 squared, or the 4 to the third or 5 to the third that were back here. Okay, let's take a look at another one. In this problem on A, they both have bases of x. So there's my x. And I am actually going to have to take my exponents and subtract them. So 4 minus 9 is going to be negative 5. Remember, as soon as I see that negative exponent, I'm going to have to put it over 1. And because of the negative exponent, this really wants to go to the bottom. So x to the 5th is going to go down here. And I'm going to put a 1 on top to help keep that x to the 5th down on the bottom. Nothing left to multiply out. There's my final answer. Okay, on B, I have exponents that are, or bases that are both p and j. So they're going to be in my answer, at least to start with. The exponents for the p are 3 and negative 3. So 3 minus a negative 3. And then negative 4 minus 6. Now, one of the things that we may have to deal with in this one, at least initially, is that those two negatives make a positive. So that means it's going to be p to the 6th. This problem right here, negative 4 minus 6, is going to give me negative 10. And I already see that negative exponent. No, I really have to do something with it. So I'll put it over 1. Since this is the only thing that's got a negative exponent, that's the only thing that's unhappy, that's going to have to go to the bottom. So p to the 6th on top, and then j to the positive 10 on the bottom. And this is our final answer. Okay, let's try one more. Let's go to this one. Okay, on this one, this 3 doesn't have an exponent. I'm going to add an exponent of 1. And I can tell by looking at that picture that both 3 and y are going to be my exponents. And I have to distribute this 4 to both numbers. So 4 times 1 is 4. And 4 times 3 is 12. Now the only thing in here is this piece right here. That 3 to the 4th we're going to have to deal with. Doing 3 to the 4th is going to be 81. And then y to the 12th in the bottom. And this is going to be my final answer.